Thanks for clicking on that link and welcome to a tour of Northwestern's Quaternary Sediment Lab, the 2021 pandemic-style socially distanced version. The lab to me is a really magical place where we get to unleash our creativity as scientists. In this particular lab, we do all kinds of strange things to mud in order to read it like a book about past climate. Some of the facilities that I find most exciting here in the department for quaternary sediment analyses include the capacity to do all kinds of different geochemical analysis, including through collaboration with our department's shared stereoisotope lab. Here in the QSL, we have a laser particle size analyzer, and we have a core scanner that allows us to non-destructively assess all kinds of things about sediment composition. For example, a scanning XRF device allows us to assess bulk sediment elemental composition and still leave the mud perfectly intact to do lots of other things with afterwards. Of course, the greatest asset we have in our lab is the people here. And this video will also give you for some of those people. You'll get to meet a few of them as they tell you more about our facilities and the science that they're doing. Thanks for visiting, and I hope we'll get to see you in the lab in person someday.
My name is Puleo. I'm a second-year PhD student working with Professor Yarrow Axford. Right now, I'm in the Quaternary Sediment Lab, and in this lab, we collect lake sediments to reconstruct past climate. You can see some of the beautiful photos that we've taken on field excursions in the past behind me, and today I'm going to show you some of the interesting instruments that we have in the lab that help us with our research. Here we have the cold room, which is where we store all of our sediment cores that we collect from the lakes, which you can see here in these tubes, at a pretty steady temperature of 4 degrees Celsius. Over here, you can see an instrument called a Geotech multi-scanning core logger. Right now, one of the instruments is under repair, so it's not here. But under regular conditions, we place a sediment core where we see this pool noodle right now, and we can measure things like color and chemistry and actually get a really nice high-resolution image scan of the core as well. Moving along in the lab, over here we have a Master Sizer 3000. Which allows us to measure grain size on sediment samples. We can place the sediment into here and it'll pipe it in, and then it uses lasers and reflectance in order to let us know what the approximate grain size is and the grain size fractions. Pretty typical sink and bench here. This contraption right here, we put sediment cores in, and we can know the depth of any given interval, which is really important for our work. Over here, we have the freeze dryer, which allows us to dry samples by freezing them. Here, we have a fume hood, and we have some chemicals in here where some people are doing some extractions. Moving into our other lab space, we can see another fume hood, some scales for measuring the mass of sediments, and over here we have another fume hood and some chemical storage space, then a high temperature oven, a centrifuge, another oven, and another long bench for looking at sediment cores. Each of these tools has its own purpose and are really essential for us to be able to reconstruct any information about the climate. I personally use these tools to investigate the climate of Greenland during an abrupt climate change interval known as the Younger Dryas about 13,000 years ago. Thanks for checking out the QSL with me.
Hi, my name is Regan Steigleder and I'm currently a senior at Northwestern and I'm working on my senior thesis with Professor Yarrow Axford. My research involves identifying insect species in sediment cores, and these are called chironomids or midges, and based on their species you can tell a little bit about historic temperatures. And our sediment cores are from Greenland, so I'm working on a time period called the Younger Dryas, and I'm currently in our microscope room and I will show you around a little bit. So this is the microscope I'm working on right now. This helps me identify the chironomid species, and I can show you a chironomid in here. This is our array of books and manuals on everything you could possibly need to know. And then here are some samples that people are working on or they just keep in here. This is the microscope used for picking out chironomids, and which will later be mounted. And then here's another microscope, same as this one. And then here are all of our supplies. But my main focus is with this beautiful microscope, and it has been my best friend for a few weeks now.
Hi everyone, my name is Laura. I'm a 5th year graduate student working with Yarrow Axford. So my research focuses on understanding the long-term history of Greenland's mountain glaciers. We travel to remote areas of the Arctic to collect sediment samples from glacial lakes. The sediment we collect has accumulated at the lake bottom over millennia and acts as a record of the environmental conditions at the time of deposition. So here's the basic idea. When the climate is cool and a glacier is present on the landscape, gray, mineral-rich, fine-grained sediment gets deposited in the nearby lake. When the climate is warm and there is no glacier on the landscape, brown, organic, rich sediment gets deposited in the lake. So in the lab, I analyzed the physical and geochemical properties of glacial lake sediments to understand how Greenland's glaciers have changed over the Holocene, which is the last 10,000 years of Earth's history. So I'll take you on a brief virtual tour and show you some of the equipment we use during remote fieldwork expeditions and some of the instruments I use in the lab. So one of our most valuable pieces of field equipment is the EdgeTech Sub-Bottom Profiler. This instrument, which we've nicknamed the Fish, uses sonar to give us information about the sediment package thickness and stratigraphy, and helps us to select coring locations at each lake site. The Sub-Bottom Profiler works by transmitting sound energy in the form of a short pulse towards the lake bottom. This sound energy is then reflected from the lake bottom and the subsurface sediment layers. That reflected energy intensity depends on the different densities of the sediments. The photo in the middle shows the fish in action on a lake in southern Greenland. You can see the yellow toefish being pulled behind the raft just below the water surface. On the front raft, I'm looking at the data in real time on a laptop. You can see what the data looks like on the bottom right. The strong reflections mark boundaries between sediment with dissimilar characteristics. We also bring a lot of equipment to take sediment cores, including a custom-built coring rig that rests on 2 pontoons. The top video is a time-lapse showing us putting together all our equipment. So to take a sediment core, first we connect a long tube, usually made of PVC or acrylic, to a heavy hammer. Using ropes, we lower the tube to the lake bottom. We pull on the ropes connected to the hammer and then drop the hammer, which pounds the tube down into the mud. Each hit usually only moves the tube down a few millimeters, so this process can take a couple hours. Once the tube is full of mud, we use the ropes and a winch to pull it out. Here we are collecting a lake sediment core at a lake in southern Greenland. The longer cores are very heavy when filled with mud and can end up weighing a couple 100 pounds. Sediment coring can be hard work, but it's also a lot of fun, and I've gotten to visit some really stunning places. Back in the lab, we celebrate all the mud we've collected. Then we split the cores open using a core splitter. Here's a core from one of the lakes in southern Greenland. You can clearly see all of those beautiful layers which contain lots of information about Greenland's past climate and its glacier history. Finally, I'd like to show you some instruments I use in the lab. This is called a Geotech multi-sensor core logger. It's equipped with several instruments, including a Barrington point sensor, a Konica Manola spectrophotometer, and an Olympus Delta Professional X-ray fluorescence spectrometer. The Geotech also includes a camera, which takes high-resolution photos of the core surface. The Barrington point sensor measures magnetic susceptibility, which is a quantitative measure of the extent to which a material may be magnetized in relation to a given applied magnetic field. The spectrophotometer measures visible color reflectance, and the X-ray fluorescence spectrometer measures the elemental composition of the sediment. All of these measurements are non-destructive, and so the sediment samples can be used for other analyses after a run on the Geotech. Thanks for watching. Hope you join us in the QSL.
Hi, my name is Grace Schellinger. I am a research lab manager here in the Earth and Planetary Science Department at Northwestern University. I have a background in paleoecology at the University of Wisconsin-Madison, where I used fossil charcoal from lake sediments to reconstruct fire history in lake basins. This experience fostered my love of paleoecology to study past climates and is ultimately what brought me to Northwestern in 2012 to work with Yarrow Axford. I currently manage the daily operations of the Quaternary Sediment, the sediment geochemistry, and the rock preparation labs for the Earth and Planetary Science Department. This includes training and supervision on laboratory instruments and safety protocols, maintenance and oversight of collections and instrumentation, and assistance with field expeditions. A wide range of things. But perhaps one of my favorite things that I get to do is help create a sense of community for the students that work in our labs, both undergraduate and graduate students. I wish so much that you guys could be here in person to check out the spaces, but I am glad to be able to say hi virtually.